Lesson 7.3, proving that a quadrilateral is a parallelogram. Let's start with a quick review. What are the properties of parallelograms? Well, first, a parallelogram, the opposite sides are parallel. That's the definition. We also have the opposite sides are congruent. The opposite angles are congruent. And the diagonals bisect each other. Today, we're going to start with quadrilaterals and use these to show they are parallelograms. If we can show any of these things in a quadrilateral, then it's a parallelogram. These are pretty much the converses of all the properties we learned on the last lesson. First, if both pairs of opposite sides of a quadrilateral are parallel, then it's a parallelogram. Definition of parallelogram, opposite sides are parallel. If both pairs of opposite sides are congruent, then it's a parallelogram. If both pairs of opposite angles are congruent, then it's a parallelogram. If the diagonals of a quadrilateral bisect each other, then it's a parallelogram. And then the last one is new. If one pair of opposite sides is both parallel and congruent, so one pair is both parallel and congruent, then it's a parallelogram. So, is this a parallelogram? Well, the arrows mean parallel. The little lines mean congruent. So I have one pair of opposite sides, parallel and congruent. Is that enough? So yes, it is a parallelogram. What about this one? Well, I've got the parallel and I've got the congruent, but they're not the same set. Either both sides need to be parallel, or both sets of sides need to be congruent, or one pair of sides be both parallel and congruent. Another option that this could be drawn with the same properties is like that, which is a trapezoid. So this one is no, there's not enough information. All right, another example. Let's find x and y to make this a parallelogram. Well, if it's a parallelogram, we have sides label here, then the opposite sides would be congruent. So I'm picking the left and the right side because they both happen to have x's. So that'll make it convenient. I can make those equal to each other since the opposite sides of a parallelogram are congruent. Going to get the x's on the same side. Get things away from the x. And divide by 2, so I get 9 for x. So if x is 9, 9 plus 6 is 15. And 24 minus 9 is 15. So the left and right sides are 15. And the top, 2 times 9 is 18 plus 3 is 21. So the top is 21. So if I use the top and bottom, the y would equal the 2x plus 3. X is 9 though, so y would be 21. Find x so that we have a parallelogram. Well, this time we have diagonals. In a parallelogram, the diagonals bisect each other. So that means this 2x is going to have to be the same as the 10 minus 3x. So just solve that. Divide by the 5 and you get x is 2. And again, it's because the diagonals bisect each other. So each half of those diagonals are equal to each other. All right, this time we have a graph. And we're going to show this quadrilateral is a parallelogram. So from the graph, we could show the opposite sides are parallel using the slope formula. We could show the opposite sides are congruent using the distance formula. We don't know anything about the angles. We could draw diagonals and show the diagonals bisect each other with the distance formula. I like the slope formula better than the distance formula. So let's go with the showing the opposite sides are parallel. So we need to use the slope formula, y2 minus y1 over x2 minus x1. Start with AB, maybe A could be x1, y1, and B could be x2, y2. So the slope of AB would be negative 2 minus 0 over negative 2 minus 0, which is 1. And then we could do the slope of CD. If I called C x1, y1, and D x2, y2. y2 is negative 2, and y1 is negative 4. x2 is 4, x1 is 2. So it looks like, well, minus negative is plus, so it looks like it's 2 over 2, which is 1. So we know AB is parallel to CD. All right, so we're going to continue that and do the other sides. So let's find the slope of BC. y2 is negative 2. y1 is negative 4. x2 is negative 2. x1 is 2. So the top is 2, the bottom is negative 4. So that's negative 1/2. Let's go AD. y2 is negative 2, y1 is 0. x2 is 4, x1 is 0. So that's negative 2 over 4 or negative 1/2. Hey, those are the same also. So we know BC is parallel to AD. And therefore, ABCD is a parallelogram because the opposite sides are parallel.